Next topic is types of covalent bonds. Depending upon the nature of formation, there are two types of bonds, sigma bonds and pi bond. And this classification of covalent bond is based upon how they are formed. Sigma bond and pi bond. Sigma bond is generally formed by head-on overlapping of atomic orbitals, and all the single bonds are sigma bond. Generally, based upon the symmetry, like sigma bond is formed between the SS overlapping and SPZ overlapping and PZ overlapping. Three types of overlapping is there. So one S orbital and another S orbital, because they have the same symmetry along the internuclear axis. When they come close, they overlap. This is the overlapping region. Here the electron density is maximum to form a sigma bond. Like this PZ, the symmetry of PZ is along the same as that of the S orbital. दोनों की सेम सिमेट्री ओरिएंटेशन सेम है, तो ये लोग या ये लोग कोई भी S के इसके साथ ओवरलैप कर सकते हैं. तीसरा जो इसमें आएगा वो है PZ ओवरलैप. इसमें दो PZ होंगे. दिस इज PZ, दूसरा PZ, to form overlapping like this and to produce this orbital. This is molecular orbital. So this overlapping is called PZ overlap. Actually, what happened here is that the sigma bond is formed by the head-on overlapping. What do you mean by head-on overlapping? If they are spherical, both are spherical, they will overlap. The extent of overlapping is maximum. But when the PZ come close to S, like head-on overlapping means like this. इसके corresponding एक आएगा side-wise overlapping, the pi bond. Side-wise overlap means like this. Okay. So head-on overlapping is possible in between the S orbital, PZ orbital, and SPZ orbital, but it is not possible between the S and PX or PY orbital due to the different orientation. Like you can draw like PX orbital is like this, and we know that here the electron density is 0. Electron density is either here or electron density is either here, above or below the plane. Now if this spherically symmetrical S block come close to it, it cannot overlap. Here the overlapping region is not there, like it will come close, it will look like this. So there is no overlapping. It means the bond is not formed. Overlapping is not possible. So at all overlapping is not possible. So S orbital cannot overlap directly with PX or PY orbital. It can only overlap with the Z orbital. Z की ओरिएंटेशन को हमें साइन कन्वेंशन के हिसाब से माना है कि उसकी जो है हम ऐसे प्लेन में लेते हैं, और PZ है जो वो S के साथ ओवरलैप करता है. Pi bond is formed by sideways overlapping. Now we will discuss and see what is the difference between these two. Pi bond is formed by sideways overlapping. Sideways, like end-to-end overlapping, you can see like this. Like at the center, जहाँ से मैंने पकड़ा हुआ है मार्कर को, वहां पे इलेक्ट्रॉन डेंसिटी 0 है. या तो ऊपर लोब्स हैं या नीचे वाला. ऊपर वाला लोब ऊपर वाले लोब से, नीचे वाला लोब नीचे वाले लोब से ओवरलैप करेगा. जैसे ये ओवरलैपिंग किस में होगी, फिर PX में होगी. जैसे ये मान लो PX है, एक PX और आ गया. आप इंटरन्यूक्लियर एक्सिस यहाँ पे तो इसकी इलेक्ट्रॉन डेंसिटी 0 है, तो ये दोनों लोब्स हैं जो ये ऊपर है ना, ये दोनों लोब्स नीचे है. तो जब इनकी ओवरलैपिंग होगी, दैट इज कॉल्ड साइड टू साइड ओवरलैपिंग. दे विल ओवरलैप लाइक दिस. Here is overlap region, here is overlap region. This is called side-wise overlapping. Okay. Because at the internuclear axis here the electron density is 0. So what happened? The product formed is like this is the internuclear axis. there will be electron density above the plane, there will be electron density below the plane. This you can see, you can use the word electron cloud above the plane and below the plane, because at the center I see that here जहां से मैंने पकड़ा है वहां पे इलेक्ट्रॉन डेंसिटी 0, ये लोग इसके साथ ओवरलैप करेगा, बॉन्ड इज फॉर्म. So this bond is formed between px px. Same type of bond is formed between py py. So py py. Okay, like this. Same. But px and py cannot form pi bond because both are perpendicular to each other. We know that px, py, pz all are perpendicular to each other. So try a single diagram. Like these are the three axes, z axis, y axis, x axis. So how will you draw pz? Here pz will be like this. Here py will be like this. Here px will be like this. So all three are perpendicular to each other. Out of these, pz forms sigma bond because its orientation is same as that of overlapping extent is more when s orbital come close to it. S orbital cannot overlap with px or py. So in pi bond there is no symmetry, as internuclear axis has 0 electron density. Electron density is either above the plane or below the plane. That's called electron cloud. But in case of s orbital like this or this, the sigma bond, the electron density is uniform. That's more symmetrical, you can say. Okay, so this is the formation of sigma and pi bond. Like all these sigma bonds, like single bonds, are sigma bond. तो डिफरेंस क्या हुआ दोनों में? फर्स्ट डिफरेंस ये हुआ, सिग्मा बॉन्ड इज फॉर्म्ड बाय हेड ऑन ओवरलैपिंग, पाई बॉन्ड इज फॉर्म्ड बाय साइडवेज ओवरलैपिंग. Sigma bond is formed, s orbital can form sigma bond, s orbital cannot form pi bond. Second difference. Third difference, sigma bond is stronger, their extent of overlapping is maximum. Pi bond is weaker than sigma bond because extent of overlapping is not, because that electron cloud not symmetrical, it's reactive rather, you can see. Sigma bond is formed independently without the formation of pi bond. Sigma bond बिना pi bond बन सकता है independently, but pi bond cannot form without the formation of sigma bond. पहले दो एटम में sigma bond बनेगा, उसके बाद अगर दोनों एटम के पास p ऑर्बिटल है, px या py, तो वो pi bond बना सकते हैं, अदरवाइज नहीं. इंडिपेंडेंटली pi bond नहीं बनता. ओके, सिग्मा बॉन्ड बनता है तीन तरह की ओवरलैपिंग से, एस एस, पीजेड पीजेड, एस पीजेड. पाई बॉन्ड बनता है दो तरह की ओवरलैपिंग से, आइदर पीएक्स पीएक्स और पीवाई पीवाई. सो दिस इज ऑल अबाउट द सिग्मा एंड पाई बॉन्ड, देयर डिफरेंसेस. नाउ इफ द सम ऑर्गेनिक मॉलिक्यूल्स आर गिवन, हाउ वी विल काउंट नंबर ऑफ सिग्मा एंड पाई बॉन्ड? दिस इज द मेन टॉपिक हियर. We have to count the number of sigma and pi bond in an organic compound. So, जैसे मैंने पहले बता दिया, all the single bond are sigma bond. जितने भी single bonds हैं, single bonds are sigma bonds. Number one. Number two, in double bond, there is one sigma bond, one pi bond. Number three, in triple bond, there is one sigma bond plus two pi bond. सिग्मा एक ही होगा, है ना? जैसे सपोज कोई कंपाउंड आपको दे दिया, उसने बोला हाउ मैनी sigma and pi bonds are there in the following organic compounds. Organic compounds आपको देखिए, जैसे कंपाउंड दे दिया नंबर 1 C CH3 CH डबल बॉन्ड CH2। प्रोटीन है, ये पढ़ा होगा आपने 10th में। तो इसमें कितने सिग्मा है कितने पाई है, इसके लिए इसको क्या कर लेते हैं, स्ट्रक्चर को थोड़ा ओपन करेंगे। CH CH। So all sigma bond, single bond are sigma. Like this is sigma 1, 2, 3, 4. Out of double, one is sigma, one is pi. This is sigma, this is sigma, this. So count the sigma bond. 4, 5, 6, 7, 8. So there are 8 sigma bonds and 1 pi bond. That's it. Okay, second example is CH3COOH acetic acid. So how many sigma and pi bond are there? Open the structure. CH3COOH. ऐसे लिखोगे। सिग्मा बॉन्ड कौन कौन से हैं? 1, 2, 3, 4, 5, 6 and 7. So 7 sigma and 1 pi. So in this way you can calculate, you can find out the sigma and pi bond in a given organic compound. Third example हम मान लेते हैं CH2 double bond CH, C triple bond CH। इस केस में इसको ओपन करेंगे तो C के 2 डबल, सी का 1, सी के 3। ट्रिपल बॉन्ड में कितने सिग्मा है? 1 ही। पाई कितने हैं? 2। तो अब इसमें सिग्मा बॉन्ड कितने हैं? 1, 2, 3, 4, 5, 6, 7। तो 7 सिग्मा, 3 पाई। डबल बॉन्ड में 1 पाई, ट्रिपल बॉन्ड में 2 पाई। सो इन दिस वे वी कैन कैलकुलेट सिग्मा एंड पाई बॉन्ड इन अ गिवन ऑर्गेनिक कंपाउंड। Take one more example. See if benzene is given, so number 4. This is the structure of benzene. How many sigma and pi bond are there? Open the structure. In benzene we have a 6 carbon, 6 hydrogen. You know it's a C6H6 like this. Count the sigma and pi. Okay, sigma bonds are 1, 2, 3, 4, 5, 6 and 6, 12 sigma, 3 pi. That's it. This is about the sigma and pi bond. Next is the valence bond theory. Valence bond theory. So this is as the name indicates, only the valence orbitals participate in the bond formation. And the valence half-filled orbital with opposite spin of electron, they overlap to form a bond between the two atoms. As you can see in the case of hydrogen, there are 2 atoms, one hydrogen, second hydrogen. Both the hydrogen has the configuration 1s1, it's also 1s1, so it has a half-filled orbital 1s. Second hydrogen also has a 1s with opposite spin. Spin of electron, that is, there should be opposite according to this VPT. So here the bond is formed by the overlapping of these two. When these two overlap, the bond is formed, get paired up. So we get a H single bond H. These are the 2 electrons which pair up. So during the formation of bond, when the 2 atoms come close to each other, the force of attraction exists and force of repulsion also exists. As we go here have, suppose we have a 2 hydrogen atom, this is your HA with 1 electron. Okay, and this is the second atom. See, this is with 1 electron, is called HB. When they are far away from each other, there is no force of attraction. Now, when they come close to each other for the bond formation, so they come close, new force of attraction and new force of repulsion that exist. So first we will see there will be a force of attraction between this nucleus. These are the new. This force of attraction is already there. यहाँ पे भी है वो, यहाँ पे भी है. But new force of attraction is between the nucleus of A with electron of B, or nucleus of B with electron of A. So these are the two new forces of attraction. And with attraction, the two new force of repulsion also exist. You can see in blue, as nucleus of HA repel the nucleus of HB, both are positively charged. Nucleus of electron of HA repel the electron of HB. So two new repulsive forces also there. Now why the bond is formed? Bond is formed because the magnitude of attractive forces is more than repulsive forces. Then only the bond is formed. That's why the bond is formed. See its energy profile diagram of this H2 potential energy diagram. It's like this. So in this side is our internuclear distance. The distance between the two nucleus, those two atoms. Here is the potential energy. So here the potential energy is 0. When the hydrogen atom are far away from each other, when they come close, the potential energy drops, become minimum and then increases. So when they come close, like here it come close, again come close, here they form the bond. When the two hydrogen they come close to each other, the force of attraction increase, repulsive forces also increase, but attraction is more than repulsion, so bond is formed. Okay, so bond is formed at this distance. When the internuclear distance is this, for hydrogen it is 0.529 angstrom, that is Bohr radius. So in this, at this distance you can see the energy is minimum. And the distance between the nucleus is minimum. अगर आप और ज़्यादा close लेके जाओगे, if you decrease the R, then these two nucleus they repel each other, and immediately energy will increase. So this is potential energy diagram for the formation of hydrogen. Hydrogen are very as far away from each other, the energy is 0. When they come close to each other, धीरे धीरे एक दूसरे के पास आएंगे, force of attraction होगी, energy drops. When the bond is formed, energy become minimum. Okay, at this distance 0.529, and this distance for hydrogen is called Bohr radius. If you further reduce this distance, because you force the two nucleus to come closer, then what happened? Then they repel each other. Because this is the maximum distance, or you can say the minimum distance at which the potential energy is minimum, means this is the minimum distance at which this molecule is stable. When you further force them to come closer, the nucleus they repel. These two nucleus, red one, they repel each other. And when they repel each other, energy immediately increase. So this is about the hydrogen. Now let's see about helium. For helium, as we know that He2 does not exist. Helium is a noble gas. So here is a helium, its configuration is 1s2, then the second helium, configuration is 1s2. So there is no half-filled orbital. Okay, there is no half-filled orbital, it means there will be no overlapping. It means He2 does not exist. Now let's see forces of attraction and repulsion. Now these are the helium atom. This is helium A with 2 electrons. This is second helium again with 2 electrons. This is say HEB. When we come close to each other like this, so we will count how many repulsive and how many attractive forces that exist among these two helium. Say attractive forces, this nucleus attract the electron of the second. This is 1. This nucleus attract the electron of the second. 2. इसका न्यूक्लियस इसके इलेक्ट्रॉन को अपनी तरफ खींचेगा, इसका न्यूक्लियस इसके इलेक्ट्रॉन को अपनी तरफ खींचेगा. So there are 4 new attractive forces which tries to make the bond between the two atoms. But if we see these two atoms again, now we will draw the repulsive forces. एक का न्यूक्लियस दूसरे के न्यूक्लियस को रिपेल करेगा. There is a repulsive forces between these two nucleus. Number 1, ये इलेक्ट्रॉन इसको रिपेल करेगा. 2, ये इसको रिपेल करेगा. 3, ये इलेक्ट्रॉन इसको रिपेल करेगा. Both are negative. ये इलेक्ट्रॉन इसको रिपेल करेगा. So there are 5 new repulsive forces. So repulsive forces are more than attractive forces. Repulsive forces are more than attractive forces. So means bond is not formed. So bond नहीं बनेगा. That's why He2 does not exist. Okay. Now let's do some more examples of VVT, formation of some molecule according to this theory. Say formation of HF. We have a hydrogen, we have a fluorine. Configuration of hydrogen is 1s1. Configuration of hydrogen is fluorine is 1s2, 2s2, 2p5. This is its valence shell. This is its valence shell. It has 1s1. It has 2s2. And it has 2p5. Here is the overlap. This half field overlap with this half field. So what were these three? These three are the lone pair on fluorine. So we'll write the structure. H single bond F. This type of bond is formed. C4 is F2. In F2 we have a 2 fluorine. 1s2, 2s2, 2p5. 1s2, 2s2, 2p5. This is the valence shell. If we draw the valence shell, this is 2s, this is 2p. We have 2s2, 2p5. This is 2s. And this is the 2p. So just write the opposite. Show the overlapping, making unpaired spin opposite. So bond will be formed here. So both the fluorine has 3 electron, lone pair. So we write F, 1, 2, 3, 4, like. So this is the F2. Okay, next. We will take an example of 5 say water. Here is oxygen, here is hydrogen, here is hydrogen. Configuration of oxygen is 1s2, 2s2, 2p4. Configuration of hydrogen is, we know, 1s1, 1s1. Its outer shell is this. So draw 2s and 2p4. Okay. S. This is 1s of hydrogen. This is 1s of hydrogen. Here is the overlapping. As you can see here, oxygen has just 2 lone pair and 2 single bond with the hydrogen. This is the structure of water. 6th is ammonia. Now we have a nitrogen, 1 hydrogen, 2 hydrogen, 3 hydrogen. Like the configuration 1s2, 2s2, 2p3. This is its outer shell. It's 1s1, 1s1, 1s1. Okay, so write the nitrogen 2s2 and 2p3. Draw the hydrogen. So this is 1 hydrogen. This is 2nd hydrogen. This is 3rd hydrogen. Show the overlapping. 1 sigma bond, 2 sigma bond, 3 sigma bond, and 1 lone pair. So structure of ammonia is single bond H, single bond H, single bond H with lone pair. Okay. 7th. So you can draw the structure of any ion compound molecule. Like we will draw carbonate ion. हमने ल्यूइस डॉट स्ट्रक्चर से इसकी ड्रॉ कर ली थी. ल्यूइस डॉट स्ट्रक्चर से भी कैसे कैसे उसकी स्ट्रक्चर बनेगी अब इससे देखते हैं. तो कार्बन, ऑक्सीजन, ऑक्सीजन, ऑक्सीजन. Carbon is the central atom. First write the configuration of oxygen. 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Out of 3 oxygen, 2 oxygen are negative. So suppose these 2 are negative. It means their configuration become 5, 5. We required, so if we draw the Lewis structure, that outermost configuration, so this is for O negative, this one, this is for 2nd O negative, this one, this is for oxygen, so total 4 unpaired electrons are required. एक इसके पास अनपेयर्ड है, एक इसके पास अनपेयर्ड है, 2 इसके पास. तो कार्बन के अंदर 4 अनपेयर्ड इलेक्ट्रॉन होने चाहिए. What is the configuration of carbon? 1s2, 2s2, 2p2. So when you draw it like this, 2s2, 2p2, it has only 2 unpaired electrons. This state is called ground state. But we require 4 unpaired electrons. How it is possible? If we shift 1 electron, this is called promotion of electron. Energy is required. Energy कहाँ से आएगी? When these 3 oxygen come close to carbon, force of attraction is there, due to which energy release. That energy is used to promote the electron. Okay, so that's known as excited state. In excited state, what happened is there that carbon got 4 unpaired electron because 1 electron from 2s that shift to 2p. So we will draw the excited state of carbon here. Like this. So mark them, say, opposite spin to show the bonding. Like this. Now show the bonding. It will combine form a sigma bond. It will combine form a sigma bond. First bond is sigma. Second bond cannot be sigma between the two atoms. Between this carbon and this oxygen, one bond is sigma. So what the second bond is? Pi. Okay. This oxygen has 2 lone pair. This oxygen has 3 lone pair. This oxygen has 3 lone pair. You can draw a structure like this. Carbon. डबल बॉन्ड ऑक्सीजन इसके साथ, तो इसके पास है 2. सिंगल बॉन्ड ऑक्सीजन इसके पास है 3, नेगेटिव है ये. और सिंगल बॉन्ड इसके साथ इसके पास है 3, तो ये भी नेगेटिव है. अब देखिए वही स्ट्रक्चर जो आपने यूएस डॉट स्ट्रक्चर बनाई थी वही यहाँ पे बन गई. कार्बन हैज नो लोन पेयर. फ्रॉम हियर यू कैन सी दिस O नेगेटिव हैज 1, 2, 3 पेयर. This O negative has 1, 2, 3 pair of electron. This O has 1 and 2 only. Carbon has no one pair, no lone pair. So this is the structure of carbonate, and you can also see the formation of sigma and pi bond here. Out of this C double bond O, one bond is sigma. Now this bond is sigma, this bond is sigma, this bond is sigma, and this bond is your pi. Okay. So this is about the valence bond theory. Our next topic is hybridization.